Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into NASA's Sentry system, a crucial tool for monitoring potential Earth impacts. It's pretty intense stuff.
Right. I've always been fascinated by near-Earth objects. So Sentry, what's the core function? Is it just flagging potentially hazardous asteroids?
Exactly. Sentry's main job is to analyze asteroid orbits and calculate the probability of them hitting Earth. It doesn't just flag them. It provides a detailed risk assessment, using sophisticated algorithms to predict potential impact dates, probabilities, and the energy released upon impact. It's not just a simple yes or no, it's a nuanced calculation.
So it's not just about identifying the asteroids, but also quantifying the risk? That's a huge difference. How does it actually do that? What metrics does it use?
Yeah, the quantification is key. It uses two main scales, the Torino scale and the Palermo scale. The Torino scale is simpler, focusing on the likelihood and potential energy of an impact within the next 100 years. The Palermo scale is more nuanced, considering the background risk of impacts over time. Both are crucial for understanding the severity of a potential threat.
Interesting. And what about the data itself? How does Sentry gather and process that information to make these calculations? It must be a massive dataset.
It is. Sentry uses observational data from various telescopes around the world. Think of it as a giant puzzle. Each observation is a piece, and Sentry uses sophisticated algorithms to piece together the asteroid's orbit. The more observations, the more accurate the prediction. The system also accounts for uncertainties in those observations, which is crucial for accurate risk assessment.
So the accuracy depends heavily on the quality and quantity of observational data? That makes sense. Are there any limitations to Sentry's capabilities? Are there any types of asteroids it might miss or struggle to analyze?
Absolutely. Smaller asteroids are harder to detect, and their orbits are more susceptible to perturbations from other celestial bodies, making predictions more challenging. Also, the further out we look, the less precise our predictions become due to accumulating uncertainties. It's a constant refinement process, improving as we gather more data.
Right, that's a crucial point. So it's not a perfect system, but it's constantly evolving and improving. What about the output? How is this information presented to scientists and the public?
The output is presented in tables and graphs, detailing potential impact dates, probabilities, and the associated energy. The color coding of the tables provides a quick visual assessment of the risk level, ranging from white, no threat, to red, significant threat. The data is also available via an API for researchers and other organizations.
That's amazing! It sounds like a vital system for planetary defense. It's reassuring to know that there's such a sophisticated system constantly monitoring the skies. What's next for Sentry? Any planned improvements or upgrades?
Oh, absolutely. Sentry is constantly being updated with improved algorithms and incorporating data from new telescopes and surveys. The goal is always to increase the accuracy of predictions and extend the time frame for which we can make reliable forecasts. It's a continuous effort to refine our understanding of near-Earth objects and improve our planetary defense capabilities.
It's incredible to think about the technology and the dedication behind this project. Thanks for explaining it all so clearly. It's fascinating stuff.
My pleasure. And remember, listeners, stay tuned to Tech Bytes and News for more updates on the latest in space exploration and planetary defense. Goodbye.
Bye-bye.